Hello viewers, I am Kausalya. Today we are going to solve problems in exercise 13.2. Problem number 6. A solid iron pole consists of a cylinder of height 220 cm and base diameter 24 cm, which is surmounted by another cylinder of height 60 cm and radius 8 cm. Find the mass of the pole given that 1 centimeter cube of iron has approximately 8 gram mass. Use pi is 3.14. So here, what are all the shapes we are discussing with? We are discussing with the cylinder, and the next thing is again another cylinder. So here we are discussing about two cylinders whose dimensions are clearly given, right? The height and diameter is given, and again the height and diameter of the another cylinder is also given. So here what is the expectation? We need to find the mass, okay? We need to find the weight of the pole given that 1 centimeter cube of iron has 8 gram of mass. That is 1 centimeter cube of iron weighs 8 grams, right? So first we will draw the diagram. You see here the thing is one cylinder, right? One cylinder is placed over the other one, right? So here you see the height of the bigger cylinder is 220 and the diameter is 24, and the height of the small one is 60 and the dia is 8. Okay, they are surmounted one above the other. So first thing is we are going to find the volume of both the cylinders, right? Only if we find the volume, then we can easily calculate the mass, right? So first one is volume of the lower cylinder, right? So this is your lower cylinder. What is the formula? The formula here is pi r square h, right? So here you see given the value of pi as 3.14, right? So just you can replace pi with that value. Then what about r? You see here the diameter is given as 24, right? You see here the dia is 24. So what about the radius? So here the radius will be 24 by 2, which is equal to 12 centimeters, right? So this is your radius. And what is the height? So here the height is 220 centimeter. So here h is 220. So just substitute the values. You see 12 square is 144, right? And again when you multiply 144 with 220, we will, that is the answer is 31680. So since we are going to discuss with cylinders, the pi value will be same, right? Pi value will be same for the lower cylinder as well as for the upper cylinder. So instead, that is in the place of 3.14, I am writing this pi as such, right? So even from the initial steps, you can write this pi, right? So the volume of the lower cylinder is 31680 pi centimeter cube, right? Since the dimensions are given in centimeters, here you have to write this as centimeter cube. Now we are going to calculate the volume of the upper cylinder. So again here the formula is pi r square h. So let the radius of the upper cylinder is denoted by this letter r, right? So even you can write it as a sentences. You see, let r be the radius of the lower cylinder and capital R be the radius of the upper cylinder, right? You just make statements. So here what about the value of r? Because the radius is given here, the radius is directly given, so the value of r is 8 centimeter, right? So just substitute the values here. Pi r square h, the value of r is 8 and the value of h is 60. So when you substitute, you see we are ending up with the answer as 3840 pi centimeter cube, right? So this is the volume of the upper cylinder. Now we are going to find the volume of the solid iron pole. So volume of the solid iron pole is, it is nothing but volume of the lower cylinder plus volume of the upper cylinder. So just substitute the values and you see we are getting the answer as 35520 pi. Now in the place of pi, you can substitute the value as 3.14, right? So finally here the answer is 111532.8 centimeter cube. The units are always mandatory to mention, right? Now we need to find the mass of the pole, right? So again when you look back at the question, you see mass of the pole is, that is 1 centimeter cube weighs 8 gram, right? So now what is the total volume we have? So the total volume here is 111,532.8 centimeter cube, right? For 1 centimeter cube, that is 1 centimeter cube weighs 8 gram. Then what about this much value? Just you have to multiply this value by 8. So once you multiply, here we are ending up with the answer as 892.26 kilogram, right? So this is the mass of the pole, and finally this is our answer. Problem number 7. A solid consisting of a right circular cone of height 120 cm and radius 60 cm standing on a hemisphere of radius 60 cm is placed upright in a right circular cylinder full of water such that it touches the bottom. So here the thing is, okay, don't get afraid because the sum is little bit bigger, right? So here the thing again, we are having a circular, that is right circular cone, right, whose height and radius are given, and this cone stands on a hemisphere whose radius is given, right? So how it is placed, you see, it is placed upright in a right circular cylinder. Again, this combination, that is the combination of the cone and the hemisphere, is placed in a cylinder, okay, which is full of water, and such that it touches the bottom. That is, this hemisphere, it touches the bottom of the cylinder. So you see, this is the diagram, right? We are having a right circular cone. So this is our cone, right? And this cone is, you see, this cone is standing on a hemisphere. So this cone stands on a hemisphere. So this is our hemisphere. And this combination is placed in a cylinder, right? This is placed inside a cylinder which contains water, right? So here we need to find the volume of water left in the cylinder if the radius of the cylinder is 60 centimeter and height is 180 centimeter. So here you see, we have to find the volume of water, okay, the water left in the cylinder. If the radius of the cylinder, right, if the radius of the cylinder is 60 and the height is 180. So here you see, we do have 3 different shapes. And for all the different shapes, we are provided with the dimensions. They are clearly mentioned, right? So here final thing is, we have to find the water which is left inside the cylinder. So how to calculate the water which is left inside the cylinder? So here the thing is, we have to find the volume of the individual shapes first. That is, you have to find the volume of the cone, volume of the hemisphere, then volume of the cylinder. It is mandatory, right? So first we start with volume of the cone. The formula is 1 by 3 pi r square h. And for this cone, everything is given. You see here the radius is 60 and the height is 120. So just substitute the values, right? So again 3 and 120, they get cancelled by 40 times, and again when you simplify, you see 60 into 60 becomes 3600, and 3600 into 40 gives you 144,000. Here comes pi, right, pi centimeter cube. So this is the volume of the cone. And the next thing is volume of the hemisphere. So volume of the hemisphere is given by 2 by 3 pi r cube, right? So for this hemisphere, again, what is the radius? Again they had given, right? Radius is 60 centimeter. So in the place of r, just substitute 60, right? You keep this pi as such. So again when you cancel the common terms, we are ending up with the answer 144,000 pi centimeter cube, right? Now the next thing is, we are going to find the volume of the cylinder. So volume of the cylinder is given by the formula pi r square. Okay, h or h2. If you don't get confused, then you can write even h. Okay, it doesn't make any difference. So what is the value of r? You see, again when you look back at this diagram, the radius of the cylinder is 60 and its height is 180. Right. So just substitute the values here. So here even you can write h2 is nothing but this is the height of the cylinder. Right. So just substitute the values. Again, you keep this pi as such, and once you simplify, we are ending up with the answer as 648,000 pi. Right. So this is the volume of the cylinder. Right. Only depending upon the volume of the cylinder, we will be having, that is, we can able to fill water inside the cylinder. Right. Can you understand? If you have a tumbler of small size, it will hold only some 20 ml or 30 ml. If you have a tumbler of bigger size, even you can fill 500 ml. Right. So that is the same concept here. Only depending upon the volume of the cylinder, we can pour water inside it. Similarly, the volume of the cylinder is equal to the volume of the water inside the cylinder. Right. So here the volume of water is given by this. But what happens here? Here the cylinder is not empty. Right. It has a cone and a hemisphere. So what is the thing? How we can find the water which is inside the cylinder? From the volume of the cylinder, you have to subtract the volume of the cone and the volume of the hemisphere. Right, because this cone and hemisphere occupy some space inside the cylinder. Right, so once you subtract the volume of the cone and the volume of the hemisphere from the volume of the cylinder, then we can find the water level inside the cylinder. Therefore, so you see, volume of water left in the cylinder is nothing but volume of water in the cylinder minus volume of the cone plus volume of the hemisphere. That is, you have to subtract the volume of the cone and the hemisphere from the volume of the cylinder. Right. So just substitute the values. Once you substitute and you subtract, you see here we are ending up with this value 361234. We have 4 zeros pi centimeter cube. Right. Now I need this. That is, if I need to convert this in meter cube, you see I have centimeter cube, right? So centimeter cube is nothing but centimeter into centimeter into centimeter, right? So here, in order to convert this centimeter to meter, I am dividing by 100. Right, since it is cube, I have 3 centimeter terms, right? For each centimeter, I have to divide it by 100. So 100 into 100 into 100, and this gives the answer 0.36 pi meter cube. And again, in the place of pi, here we are using 22 by 7, right? Even if you use 3.14, you will be getting the same answer. So again, when you simplify, we are ending up with the answer as 1.131 meter cube.